Hey, let's take a look at your assignment for LT7 of MT8. Don't forget your name. Can't give you credit if you don't put your name on it. First 20 questions on this assignment, I want you to complete those in Alex. On question 21, we've got this square, and we know the area is 16x squared plus 40x plus 25. Now, since we know it's a square, we know the length and the width have to be the same. This is the definition of perfect square. So in other words, I know my area is a perfect square because that's the area. So I'm just going to factor that. The square root of 16x squared is 4x. The area, or the square root of 25 is 5. So I get 4x plus 5. That's squared. That's what that factors to, which means each side is 4x plus 5. Now we can double check that just to make sure. If I take 4x times 5, I get 20x. Double that, I get 40x. It works out perfectly. And we can approach question 22 the same way. We know for a circle, the formula is pi times r squared. In other words, r squared is 25x squared minus 40x plus 16. Notice my middle term is minus, so that tells me how I'm going to factor that. That's going to factor to 5x minus, and the square root of 16 is 4. So we get 5x minus 4 squared, which means each side is 5x minus 4. Notice the choice is 5x minus 4 squared, but that's r squared. So I just want one of the factors, which is 5x minus 4. Now when we take a look at, whoops, I didn't want that. I just wanted to move my page. There we go. I want to factor x squared minus x to the 16th minus y to the 16th. Well, that's a difference of squares. So I take the square root of x to the 16th, that's x to the 8th, plus y to the 8th. And we're going to take that times x to the 8th minus y to the 8th. Notice x to the 8th minus y to the 8th, that's a difference of squares again, so I can factor that. That's going to be x to the 4th plus y to the 4th times x to the 4th minus y to the 4th. Oh, I get a difference of squares again. I'm going to keep this going for quite a while, so I get x squared plus y squared times x squared minus y squared. And once again, difference of squares. So I get x plus y and x minus y. So my answer, when I factor this, is going to be x to the 8th plus y to the 8th times x to the 4th plus, whoops, I just noticed I wrote that in, not typed it in wrong. That should have been a 4. Hopefully I said the correct answer when I did that. Just wrote it down wrong. Times x squared plus y squared times x plus y times x minus y. Now, let's look at our choices. We can definitely see F is not the right choice. G, x to the 8th plus y to the 8th, x to the 4th plus y to the 4th, x squared plus y squared, x plus y, x minus y. So the correct answer is going to be G. H is close, but they did the x plus y twice, and then J doesn't go far enough. Okay, question 24. true or false, all binomials have perfect squares and to the terms to be factored. No, all binomials that are perfect squares have perfect squares and to the terms that can be factored. Yes. Oh, binomials. Yes, that's true. Because if it can be factored, it's got to be in the form of, whoops, let me write that down here, of a squared minus b squared. So what we're saying then is my first term has to be a perfect square, and my second term has to be a perfect squares. And you might be able to factor something out, but that essentially is going to be true.